All right, we'll go ahead and get started. Thanks for coming. Appreciate you if you guys made the trek over from one of the other hotels. I appreciate it, down here to MGM. My name is Jeremy Oki. I'm a senior director with Cisco's Cloud Platforms and Solutions Group. So I run a technical integration team. So today, specifically, we're going to talk about successfully migrating business applications to AWS. So a little bit of overview of what we're going to cover. We're going to talk at a high level. I'm going to talk about how we're actually doing it, and towards the end I actually have demos of how we're actually doing it. So we're going to kind of progress through some slideware into some actual content, screenshots, and actually into some live demos end-to-end of how it's all being done. And then we'll have some time at the end for questions, I'm sure. So we're going to talk about what's driving you to the cloud, what are the challenges of doing so, how does that migration flow look, how do we use some tooling to bring the whole end-to-end story together, and sometimes when you're there you need to come back for various reasons. So we're going to kind of talk about that process as well. So not going to tell you guys why you're going to the cloud. We're going to hit on a few points here. You may be out of capacity. We have some customers that sometimes the electric company can't bring you any more power to your data center, or you've already moved to 52 U racks to go as high as you can and there's just no more. Or we find a lot of times people are using it for like disaster recovery, or you may have an infinite number of variabilities. I need faster. I like all the new services I heard them announce this week. Obviously AWS innovates at an incredibly fast pace in new services, so one of these drivers or more may be relevant to you. What is the problem for enterprises moving? This is actually not new. We've been through several iterations of this. We used to do physical to virtual, and then we did virtual to virtual. Now we're doing virtual to cloud. So a lot of you may actually have experience with this, data center consolidation, or when you were trying to actually adopt virtualization 6-10 years ago. A lot of times, though, people just focus on the actual tactics of the migration and not what's involved on either end. The planning, what am I actually moving when I move it there? You'd like to say that when you do something, where it ends up is the same or better, correct? Otherwise, why'd you move it? And so there's a lot to that. There's also a lot of people involved in this. A lot of times a technical initiative doesn't consider the other stakeholders. We've got operations people. Do we know how the app is actually architected? Dev guys, are we confident we know every code dependency? Devs never put hard-coded IPs in database connection strings, do they? They always use DNS names and dynamic resolution. You never find something, an NFS mount or something you didn't know about. So devs will be honest and say, are we even sure that we know everything? The business, do we understand the impact? You told me you're going to move and I don't have a choice because the data center is being shut down, or we've made the strategic decision to move to AWS. Are we comfortable as the line of business owner that we know what the impact is going to be to the user and how we mitigate it or back it out or even measure it? So you need to have 100% confidence in this process, and it can be a long process, potentially. So we're going to talk today about how do we handle some of these issues and how do we maybe even shorten the time and get it to be a very agile process. Okay? So let's talk about planning. Large sets of applications. People who typically are looking to migrate, I know we see a lot of customers that set corporate initiatives. We're going to move X percentage to AWS by 2020, kind of a 4 or 5 year time horizon, giving you practitioners plenty of time to figure out what X percent actually is a good candidate to move, and do I even know what makes up those percentages? Do I have visibility into those apps, how they work, who they talk to? Do I have performance integration, and what do they even talk to? Performance information, and do I have integration information about what they connect to? So I asked you guys a kind of low-tech polling question earlier, and some people maybe you didn't raise your hand because you didn't want to admit it was your first reInvent. We're going to be high-tech the rest of it. I've got a couple polling questions. If you want to participate, it will ask you your name, but you can skip it if you want. But I'm actually not showing anyone's name. It's just going to be multiple choice, A, B, C. So throughout this, we're going to have a couple questions, get a little audience participation, and maybe you'll see how your peers are actually doing in this topic. So if you go to this URL, as I go to the polling slides, your page will refresh, and you'll actually be able to vote real quick. And real time on the screen, we'll actually see everyone's polling pop up, okay? So, first polling question, and it even worked, how about that? Does your organization have a good understanding of all your applications deployed and their dependencies? Some of you may say, you know what, we just deliver virtual machines. Somewhere else in the business, someone actually does something with line of business applications. A lot of people, there's a smart guy in the corner who knows something about App 1, there's another guy over there who knows a lot about App 2. So give it a second for everyone to kind of fill in. All right, see, it's anonymous. You guys can be honest. No one will know it's you. All right, so we're seeing a trend here. I'm not surprised. Tribal knowledge is actually what we find a lot of times. You have a certain dev team or within the line of business, or there's a certain focus in IT that's more maybe application-centric, and they tend to know a lot more. It's not institutionalized. It's not well documented. Truthfully, cloud introduces a bit of a problem as well. We have a lot more dynamic nature to our applications. A Visio diagram from a year ago may not really be any good, because the truth is the guy who wrote it, he left. There's been 3 revisions in the app since. No one went back and revisited it. Or you moved this app to the cloud already, or someone added auto-scaling, or a myriad of new services from AWS got added, and the drawing or the documentation is no longer current. Okay? All right, so everyone's got the hang of polling. Excellent. So planning requires an understanding of your applications. How do they connect? Who talks to who? When I'm looking at what do I have, I need to know who talks to who and what the order of execution is. Quote from the quote actually talks about if you attempt to move a monolithic app into the cloud without refactoring it to microservices, is the exact quote, you will lose many of its advantages. So that's true, but sometimes you have applications you just need to pick up and move. You're not prepared to do an initiative to modernize it, to move it to cloud ready or cloud native. So even moving things to the cloud, as you'll see in some of the later demos, the performance increases we see are measurable. So sometimes just picking up the app and moving it as is may be better because you get a faster capacity, new hardware that you're on, etc. So quantifying success, we need a baseline. I mentioned all those interested parties before, dev, ops, business. They each have their own different interests. Devs want to know about errors, 404s, when things get unlinked when you move it. The ops guys want to see technical metrics. I want to know, did the web server respond in a fast enough time? And you're looking at things like disk IOPS and milliseconds of page loads. What does the business want to see? End user experience. You'll see lots of stats of if I can keep a customer in my shopping cart for under X number of seconds in checkout, I convert. If I can lower that by half a second, the conversion rate is bigger. So a lot of the business guys are actually looking for how can they get their end user experience to be great and how can they actually get everything faster. So we're looking at, we had all that working because it was a working application. Do we know what's going to happen post-move? Do we have a way to actually know predictively or without finding out after the fact from our end users complaining what's going on with the application post-move? So I'm going to kind of talk about the migration flow. We need to do this application discovery. We need to do a pre-baseline. How did it perform before? We then need to actually do the migration. We then want to do a post-performance baseline. Does it perform the same or better as it did from the source? And finally, we actually want to do that, the comparative performance, and bring it under management. So I'm using a couple specific products. Some of them are Cisco, some of them are third party. Pretty much, I think everyone here that I'm using is actually out here on the show floor. Not to say there aren't other products that do this. I've picked these for a couple reasons. Maybe they're more API driven or they meet my requirements. There are vendors that do each of these steps in different ways, and you may find one's better. So I'm not prescribing that there's only one way to do this, in fact. You may even own a similar product that does the same thing. I'm just showing you kind of an art of possible of what's possible with a handful of products in the solution. Okay, so iQuate is doing our discovery for us. AppDynamics, product that Cisco acquired about a year ago, is doing our performance baselining. We're using Cloud Indoor as an actual lift and shift product, so they're picking up, flying the bits somewhere else and doing the fix-up and things that need to be done. We're then using AppDynamics again to do the post-baseline. And then finally, how do we actually comparatively look at the data? And then who's actually orchestrating this? I could go through each one of these products step by step manually, but how am I actually putting this into a reproducible process that is quick and can be more agile? How do we get that 5.5 months down to, say, weeks or less? And then there's also another challenge. I just moved from my familiar operational environment on-premise out to the cloud. How do I actually do ongoing performance and management of applications when I have a distributed environment? So the latter products actually are also doing the day 2 kind of ongoing operations. So iQuate specifically, I'm doing the application discovery. I am enabling the AppDynamics agent. So once we install that agent, we now can start to collect the data into the system of what's going on dynamically. This isn't just a snapshot. We're constantly generating this information from these 2 products of who's talking to who, because sometimes applications don't just discover point in time. monthly processes. Maybe all of a sudden something happens, it only happens at the end of the day or at the end of the month. So these are things that are happening ongoing during the process. How we used to a lot of times do data center migrations, I've seen them before, where we'd send a contractor in, they'd go rack by rack and do inventory, look at every single server and see what's on it. They'd put a big spreadsheet together, and then 6 months of analysis. In the meantime, the data center actually changed, moved, stuff got re-racked, stuff got unracked, applications changed. So we're trying to do this with a tooling that actually is dynamic and real time and is going to bring you all the information, so you're always making the right decisions with the latest information. Okay? Finally, we're saving that baseline. We want to have the historical information of how the application worked, and then we get into the next set. I want to actually migrate this application. I now have picked what I want, and I'm going to pick it up and move it. Now, I'm going to be honest, the one thing that you really cannot highly automate is picking what to move. And the reason that is because most people don't do a discovery of 10 or 2 or 5,000 or 10,000 VMs and then say, pick it all up and move it. Nothing could possibly go wrong. No one's going to ever say that moving 10,000 VMs. So oftentimes the analysis of going through and picking waves of implementation and migration is typically how customers do it. You usually pick the stuff that's safe, dev, critical applications, test it, kind of refine the process, and you tend to go to waves, and the last wave is those things that really make your business money, or generate a resume-generating activity where you go look for a new job when you mess it up. So typically they happen in waves. We then want to do the performance baseline again. We then want to compare the performance, okay? So day zero operations, a little bit of what we're actually doing more technically. So we're starting to dig a little deeper into what each product does and some of the steps that are involved. So when I actually get to the live demo here, you're actually going to see through what we're doing, each of these individual steps occurring in each product. Okay? Now, a little graphical here. We're going up. iQuate is sending the information it gets from the discovery to CloudCenter. Okay? So here's an iQuate screenshot. They've gone out and discovered the environment and brought me back an application dependency mapping. I can now see what's talking to what. I have an app business service. It sits on this virtual machine. I have their name. I have all this information. This has now all been brought into CloudCenter. Okay? So let's talk real quick another polling question. Do you already have full visibility into application performance today? I just showed you, a product that went out and showed you who talks to who with a quick discovery. Do you guys already own that today? Technical tools, but maybe they don't give you. Sometimes we have tools that show us just lists. Other times we have tools that aren't dynamic. Some of the older application performance management tools were fairly static. You had to tell it about an application and then it knew what talked about it, but it's not dynamically learning the environment and reading changes real time. Okay. Few people using the AWS services even. Any Amazon guys in the room? I threw that question at the end for you. Okay. So it looks like more than half, have technical tooling. And we've got some that are getting into the dynamic realm. Good, all right. So you guys kind of see where you stack with your peers now. All right, looks like everybody's done. Okay. So now that we have that application dynamic structure, we can now do smart things. CloudCenter can now take the list of what you actually want to do, the first wave that we're going to migrate. I can actually push the AppDynamics agent to it from CloudCenter. So how do you actually get these agents installed? It's an agent-based product. So what's going to actually push the agent? So CloudCenter is pushing the agent in this scenario and starting to bring the traffic back to the AppDynamics controller and collecting the baseline. We're building that performance data and kind of looking to get a feeling of what's going on. Okay? And so here's what it actually looks like in the product. We're going in, we see the virtual machines. If you remember, we saw App OC BR1 and BR2 in the iQuate screen. We now have those brought in as managed virtual machines in CloudCenter. We're now installing the AppD agent, and on the right-hand side, we're actually starting to see what a performance baseline looks like. And this is the business users, average response time. This isn't how many IOPS am I getting. This is the end user's end-to-end experience is X number of milliseconds, and we see this many calls per minute actually coming from the application. So an application-centric view of what's going on. Okay? Now we get into the migration. We have what we need to know of what source looks like and what good looked like. We're now going to trigger this. So CloudCenter is actually calling and sending this information. This is all API-driven at this point. I'm using a lot of screenshots here and visual. You could automate the whole thing end-to-end because all these products have APIs. So CloudCenter is now calling Cloud Endure and saying, please start doing this action on this set of things. So Cloud Endure is the engine doing it, but it's being directed by the orchestration to actually do it. So the process of lift and shift and fix up and all that, they have a booth if you guys want to know more to exactly what happens in the nuances. But you have to actually send the bits there and then convert it. It's no longer a VM or an OpenStack environment. You now need to send it, convert it to an AMI, do the cloud fix-ups, change NIC drivers, storage drivers, et cetera. So the migration process is actually doing all that fix-up, so it's now a bootable, working image within that new target, okay? And so now, here's the screenshot of where we're actually giving a self-directed. So I said I could automate this. I also created a button here, move to AWS. So if the user actually wanted to start doing this themselves, they saw the baseline data. They could actually self-do the move. You've given the tooling to whoever the end user is, line of business, development team, an IT operations segment. They're actually pushing the button saying, please move this to AWS. Okay? And then so you actually see what's happening within Cloud Endure. They're actually receiving the request. They're starting to do the initial sync. They're telling you how much data they're moving and the progress of what's actually happening. Okay? So continuing on, we're now going in and we need to bring this new target back in under management. So we're bringing it in, we're installing the AppDynamics agent, and we're going to start comparing the data again. So now we have a side-by-side comparison. We saw what it ran like before, 64 milliseconds out overall response time. Now we see 58. So it's the same or better than where it was before, and you see kind of the graphs are there. Now I'm using a lab environment, and I moved to AWS, so we're seeing kind of what I would expect. I have an environment that's underpowered, older hardware. I moved it out to AWS. That's a production-grade environment, newer technology. I should see better performance. I got the benefit I wanted, and it's provable. Okay? So this is what your business wants to see, though. How many users? I have my conversion rate. So I can technically look at it and see things like milliseconds, but how many active user sessions do I actually have? Do I have more? Do I have less? What's my user conversion rate? What's my revenue? Now, these things are actually within, this is AppDynamics screen. These are actually programmable. Your business people can say, what's meaningful to you? How many people do I have in the shopping cart? How much ticket sales did I have? How many bookings did I have? That's stuff that they all configure within AppDynamics itself, and we're just showing it a side-by-side comparison of whatever's business relevant. What's the user experience look like? You notice my lab environment was a little more variable. Now we kind of actually got a nice, more consistent response curve by moving to AWS. And I saw my conversion funnel actually increase. So I went from a 5% roughly conversion funnel to a 14% conversion funnel. So this means something to the application owner, the line of business. Okay? So I mentioned now we want to actually do something with it. We've moved it there. I don't just want to dump it there and no longer do something with it. So the tooling can stay in place because now you can actually see ongoing performance management. You can actually do things like continue to manage the virtual machines in the application environment, upgrade it, patch it, move it back potentially. And so the combination of those two things, that is what we at Cisco do. So let's actually look at a demo of what this looks like. So if you guys want to see it in action, let's kind of talk through a little more depth of what's going on here. Okay, so we're in a vCenter environment here in the lab. We're going through and you see what we have, a number of virtual machines. We don't really know what these are from this view. We've now gone over to iQuate. It's doing an agentless discovery. So this is an agentless product. There are agent-based products as well. So just to be fair, can AppDynamics actually do APM discovery? Yeah, but you notice I had to push an agent. Cisco has a product called Tetration, which actually can do agent-based and a network ASIC-based discovery that's agentless. You may already own products that also do this. So there's not only one way to do this, but if I'm trying to all of a sudden go discover 10,000 virtual machines in a database, agentless is what I picked in this to have an advantage. So all we're doing is giving it credentials, and iQuate is going out and trying to use these credentials to all the systems. And you see some things here like red, it failed. The systems that we were looking at, like this BR1 and BR2, we successfully discovered them, and now it's pulling the information, IP address, communications, what it is, et cetera. And it starts to build this topology of what's going on in the product. Okay? So now I have my OpenCart application. So simple e-commerce PHP-based site. So I've got it, it's running. This is what you're running on-premise today that your line of business cares about. I've got CloudCenter here now. I have unmanaged virtual machines. So I've taken the feed from iQuate, and I'm bringing these in and bringing them under management so the system can orchestrate the end. This is where the manual step of what are my waves of what I want to do. I can discover 10,000 things, but maybe I only want to bring the first 1,000 in. So the human analysis has occurred, and now you're bringing them in. I'm giving them scope. This user should be able to see this. So now the user could actually self-direct. So where I showed buttons earlier, this is where the user can actually now self-direct and do the rest of this on their own, or you can do it on their behalf. So we're installing a CloudCenter agent, which gives us the ability to execute things against it. You could provide user keys or user passwords here. So probably the same credentials we gave the discovery process are now the credentials we're using to set up the system. So we're doing the second virtual machine now because our topology map had 2 VMs, BR1 and BR2. Okay, so now I have 2 managed virtual machines. Now we're installing the AppDynamics agent. Same thing, self-directed. The user doesn't actually know how this is done. We've just provided a drop-down, so the agent's now being installed for AppDynamics. So now we go into AppDynamics, and we see this PHP brownfield application has been discovered. We see the same kind of topology. So remember, I said there are other products that do application dependency mapping. AppDynamics does as well, but I needed an agent to do it, not just credentials. But we've pushed this agent, particularly here now we're looking at the transaction flow of that and what makes up this end-to-end experience. So you have to have some knowledge within APM systems usually of how do I actually progress in the system. I want to log in, and then I want to go to a shopping cart. So the users actually can use these systems to define that, and that's what you're seeing here, is the end-to-end experience of that process. Okay? So now, again, I could automate all this end-to-end with APIs, but I'm letting the user self-direct. They're now comfortable with what their good looked like before. They're now going in and saying migrate to AWS. They're directing the process. They're providing the credentials. The process is actually occurring. So now, CloudCenter has now API sent work to Cloud Endure to do. Cloud Endure is now actually running a job, synchronizing the data. You see data replication here. If you have 100 gig here to move, 100 gig takes a little time to move, so we're doing a little video editing here. But now we've got these over in the new cloud, and we're importing. These are now managed virtual machines from AWS. So they're no longer managed. They've been basically decommissioned from the source, and now they're being brought back in. This is all automatable as well. We have APIs for all of this, so it's a little less magical if we show you everything end-to-end. But just like we can click in the UI, you can also just make an API call as part of a consistent workflow. So we're starting to see what we have in the cloud, what it costs. Now, we haven't touched the AWS console here, but just to show you, these are now running in AWS. They have all the familiar things you saw, instance IDs, instance types, they're running, they've passed. These could attach, but we have a public IP address here. We went to look it up just to kind of show you, okay, the OpenCart application is there. This could all be, normally we automate all of this. We actually go re-register it in DNS, we reconfigure load balancers, using a simple example here, but all of this can be automated. We're now going into AppDynamics again. This was moved. It already has the AppD agent. It's re-phoned home probably to the AppD controller, or if something happened, it was uninstalled, we could push it again. And now we see the same kind of flow of what our business application flow looks like and how a user consumes our application. Everything's green again. The business transactions are flowing. And now the system's starting to collect the post baseline. So we head into the dashboard, look at the side-by-side comparison, and now we see your average response time was a little more variable. I see a lot more consistent performance. Everything's better. I now prove to the business I have the same or better performance as I did before. Okay? So sometimes you do want to move it back on premise. Maybe it's holiday time. Your business may say, own the base, rent the spike. So we're only using the public cloud for capacity we need that we don't already own in our own data center. You may find that maybe Dev runs there, and now you promote the application to production. Let's go ahead and bring it back. Lots of reasons. Regulatory landscape changes. Your business moves from one country to another, what have you. So the ability to bring it back, this is reversible. So the products that do the discovery, that do the fix-up on moving the image types back and forth, the whole process is reversible. Okay? There's a couple other scenarios here, so we're going to get into kind of more complex scenarios now. It's easy to say, let's move the whole thing and pick it up and fly it to the other environment, but what happens if I actually need to use both environments at the same time? So I need something that goes ahead and builds the connection between my on-premise and my public AWS. I may have multiple regions. I may need to build an East Coast and a West Coast. And so now I have that one-time setup. My connectivity is good between my two environments. Now I have CloudCenter. Let's go ahead and deploy an application. And maybe I want to stretch it. I have a mobility application. I want the presentation tier to be close to the handset. I want to use content distribution networks. I want to use advanced services from AWS. But I want the database to be back on-prem. It's a database that's not just movable because maybe it's a huge database that 50 applications all share, and you've only decided to move the first one, the mobility application. So we're stretching the deployment across multiple environments. So can we use this process to pick up some of the application and move it? Maybe the top tiers go, or redeploy net new and split it? Yeah, both are scenarios that are supported by the tooling or CloudCenter. So what happens, though, when the database is an issue? So let's real quick, last polling question. Let's just talk about your databases. Do you deploy databases using a big central scale-up environment? This would be like Oracle RAC. You have a big physical environment, lots and lots of databases run on the environment. You don't deploy new instances. Are you running dedicated instances? We are starting to see a lot of let's just deploy a dedicated database instance specifically for one database. Or you've already kind of decided, let's move everything to AWS, and we're using their platform services like RDS, DynamoDB, Aurora. Pretty good mix. I have seen B. B's become pretty popular the last few years. Licenses advantages. A lot of times if you set up a resource pool and license the whole pool, you can run as many databases or as many virtual machine instances on the physical server, so you're licensing sockets. So there's been a lot of licensing advantages for B over the past 5 years. Okay. I will tell you, B is the most helpful. If you're in the situation of A, it's pretty hard to do the whole first scenario I talked about. If you're in the B situation, it's pretty easy to actually pick things up and this application is fairly self-contained. I can pick it up and move it. I don't have a lot of cross dependencies. I now can, I've always been able to patch it in place, but it's a little easier to move the whole entity as one thing. It's a little harder to do a full wave of lift and shift of many applications if you happen to be in that first category. So not saying it's wrong. There's a lot of performance in A. Your dependencies get a little tougher to manage. That human analysis portion is a little more involved in A, and there is no way to automate that, unfortunately, today. Okay, so how are we solving the database problem? So we're using another product here to specifically solve it. They are here out on the floor as well, not a Cisco product, ScaleArc. There's other products that do this, but there's a couple different variety scenarios here that we're going to talk through. I want to keep my database on-prem, but accessing my database from AWS is a performance problem. It's a long distance. You're going from a US-based data center out to a European mobility presence, and that's just too far to go to have the application read. Or it's a shared database, and a lot of other things hit it, and so you have an adjacency problem. You can't just pick up the database and move it. So in this scenario, we're actually using ScaleArc not to move the database, but to create a perceived local cache. Okay? So let's go in here and kind of talk through what this looks like. So again, we're in VMware. We've got some databases here. It's an on-premise MySQL. We see its private IP address, 10.36 something something. In CloudCenter, we've got this as an application. So we're going to actually go in here and show you what that looks like. So I'm actually deploying ScaleArc to AWS here. Okay, so this is a new deployment. Instead of migrating here, I'm just redeploying the front half of the application. A lot of times applications are fairly recomposable this way. A lot of the logic is in the database, and the actual upper tiers are actually destroyable and recreatable. So instead of migrating, maybe don't move 500 web servers that are 100 gig apiece, remodel the top tier and just completely redeploy it, and then we're putting ScaleArc underneath it. So we're still keeping where all the data is that the application depends on, but the top part is actually fairly reproducible and reconstructible. Okay? So we're deploying. The user here is going through picking his cloud, picking his instance types, deciding how many instances he needs, what cost he wants. We're keeping the on-premise MySQL here. So this one we're doing a full redeploy of the application. Okay, so now through the magic of video, everything's green. We just deployed an app in seconds. Realistically, it takes a couple minutes for this to be deployed and to set up the application. Okay, so now the application is up and running. We can now see our things in our cart we can buy, just like before. We now can go into AWS and we see that we've only deployed the actual front side of the application and the ScaleArc appliance into AWS. The database was deployed into VMware. Here's where we actually see we've configured ScaleArk to have a replica. Okay, right now we're not doing query caching, so we didn't automate everything because we actually want to show you what did it look like before. I had the ScaleArk appliance there, but it actually wasn't caching. Okay, so we were just seeing everything through basically a remote connectivity, essentially through a pass-through appliance. So it's not actually doing any acceleration. Okay, so the cache is inactive on the left. Queries per second, we're actually using a JMeter here just to simulate traffic load. So we have a pretty consistent kind of bang on the system because we've got a script that's running here generating the traffic. Okay, so we see that the response time is poor. 8 seconds is the user experience to open pages. And so this is AppDynamics again, looking at the end user experience through that business logic. And it's not great. You probably have some websites that you use that 8 seconds is fine. Okay, so we can go in now and kind of turn on the transparent cache. Now, there are APIs for all of this. Could I have set this up from the gate, turned on cache, had everything going great, and AppDynamics would have seen the performance? I could, but to show you kind of the before and after here, we're kind of doing some of this manually in the UI. So we've gone ahead and turned on the caching now. Now, what's happening is as queries come in, we're building a read-ahead cache. The ScaleArk guys would probably gladly tell you all about what else they can do. So now we notice that our end user experience has gotten much better. We went from 8 seconds of response time down to just over 2. It's still not a full localized database. At least I've brought some closer, so my end user experience has gotten better. Okay? So what else can I do here? So ScaleArk's a pretty cool product, and there's other ways that can do this as well. I have MySQL on-premise, but I want to use RDS. Well, RDS has a MySQL option. Can I actually keep my MySQL database, but then also use an Amazon platform service, RDS? You can. So there's different products that do this, and they have different capabilities. ScaleArk particularly supports a couple databases, can actually do the transactional syncing between your private build and what is something you're paying Amazon to run well for you. Okay. So let's go back to a different way of looking at this. Again, we're back in vCenter. We are looking at the MySQL database here that's on-premise. Back into CloudCenter, we're going to go ahead and deploy a full stack now that actually includes the ScaleArk appliance, but also provisioning an RDS database. So before I only had the presentation tier and the appliance. Now I have the presentation tier, the appliance, and I have 2 databases behind the appliance. Okay? I have the ability to have the on-prem and the public service. So now the user is actually consuming this. So this is a catalog item. A user is going in and choosing this. This could be a dev, test, or prod team. So we're not going to get into all the details of CloudCenter. But I can now choose where I want to go, what's the right cloud. This is all kind of what the platform controls. What instance sizes do I want? And right here I'm actually going to choose, hey, I want to go ahead and deploy a copy of my on-premise MySQL on-premise. This could connect to an existing one as well. Here we're just, for simplicity, we're choosing a full redeployment. If you're a dev team and wanted to see this, they could deploy over and over and over, dev to test to stage to prod, so they'd have the ability to kind of keep iterating and improving over time. Same thing, CloudCenter is now going out and doing all the orchestration, dropping all the products, calling Amazon RDS, setting up the databases, and then now you see that we not only have OpenCart RDS, we also have a ScaleArk appliance. And then if you go into RDS here, you actually see we have a database, it's running, it has a name, job instance, something in the East Coast. Here it is, it's all set up. Okay? Do you have to use the Amazon console at all for any of this? No, we're using all the great APIs that AWS provides to do all this, just kind of showing you what it looks like. So now inside ScaleArk, you notice we actually have 2 systems behind the appliance now. We have the public side and the back-end side. Okay? So response time is still not great because we haven't turned on any of the acceleration. So what you're going to see now is the product's actually doing transactional replication. So we're actually taking transactions from the on-premise location and we're doing transactional syncing through another product to then transform what is your private build of MySQL to an RDS service MySQL and setting it up. So this is the same thing. This can be done with APIs, but we're going in and actually setting up where the public RDS copy is now a read-write instance. So now everything is happening via the RDS. Our test platform now shows actually queries hitting the blue rather than the other. We go into AppDynamics, and our end-user experience is measurable. We actually see the on-premise database had high latency. Actually running RDS out in the cloud runs much better. You also notice that we were about 2 seconds before. We're now very, very low, because now we have adjacency. So we have an adjacency between everything's out in AWS, so all the queries or read writes are occurring. Now, the other application that needed to stay on-premise because you didn't decide to migrate that yet, it's still there. The product's actually doing the transactional synchronization. Now, are there other ways to do this? Yeah, you have some of your database vendors actually have this capability as well built into them. A lot of them have APIs. We're just showing kind of one art of possible here to solve the problem of, I just can't pick everything up and move it. All right. So a lot of stuff here. A couple things. We have time for questions. So there are people with microphones. So we have about 15, 20 minutes for questions. A lot of this, the videos, sometimes they're a little hard to see on the screen. We actually have scripts for a lot of this and show you kind of what we're doing. We're going to post all of it up to communities.cisco.com. These videos are actually being posted in a couple days, but probably tomorrow or Monday we'll actually post some of how we did this. You can see what we did behind the scenes to do it. So appreciate everyone who's got a bolt, but for questions, microphone?
Yes, I have actually two questions for you. The first one, how do you compare this stack to the new migration stack that Amazon just presented to us? It's both database and images from VMware and everything. And the second question is, in my case, in reality, I have a data center with my application running, and in order to cut over, we have to first build the Amazon. And it's not one-to-one. It's not just the lift and shift, because sometimes you have to deal with different load balancer, different firewalls and security and accounts, Active Directory. So there's a lot of things around the application that it's not one-to-one. And so we actually build the environment on Amazon, and then we plan to do a cutover of the database, basically replicating as much as we can. And then the cutover, since we don't want to have a downtime, we planning to just take the log, maybe 3 hours, last 3 hours, stop the ongoing one, the live, and then cut over the remaining, and then you bring up Amazon Live. So that wasn't really articulated in your process. Okay. How do you actually mitigate that?
Yes, let me answer your first question. So some of these other third-party products are actually part of what Amazon has called a migration competency. So they've actually been developing a migration competency for a while. The products we used are actually are members of that migration competency. And actually that for Amazon includes professional services companies, partners that actually are part of that. So we're participating in that migration competency. So some of this needs smart people to still look at it. So that's the first question, this is actually complementary to the migration competency from AWS. Secondly, the complexity of apps. So we used a simple app here to not lose people. Do you sometimes want to also convert an F5 load balancer on-premise that's a physical appliance to an Amazon ELB? Absolutely. Now, I didn't want to get too much into individual products. CloudCenter can actually do some of that. You can actually drag and drop. I can drag off an F5 load balancer and drop on an Amazon ELB. Sometimes, though, there is featured parity. I picked databases because actually they're really important, and it's actually easy to do transactional replication. Sometimes you get into situations. Can I just swap out a commercial production load balancer I've had for 10 years and move to the provider? Maybe not. There might be a feature. A lot of them are very evolved now, and things like SSL offload but maybe the vendor you've liked for years, you have a lot of complex business rules where you can't replicate all those. So there does have to be some rationalization. So some of the competency partners, I used a quote from Contino. They actually are one of those companies that actually does DevOps optimization, app rationalization. There's a lot of global systems integrators that do that as well. So I don't want to diminish that this is magic. There's still some stuff sometimes that has to occur. But if you actually put it into a topology that's reproducible, then at least you can iterate on it. You can move around the Lego blocks that make it up. I want a red car, you want a blue plane. We might use different load balancers, but we share the same database, or we can share the same automation scripting. We're both using the same AppD agent process. We're both using the same move to button that uses a third-party product. So as the application stack gets more complicated, you do have to kind of figure out what's the feature matrix and things like that. Most of the vendors, though, if for example, let's just say ELB, it doesn't have one feature I need that my commercial one does. Most of those vendors also have virtual versions, and so for us, usually it's within like CloudCenter, we're using an F5, for example, or an A10 or AVI networks. We can deploy it both on-premise and in AWS, and you're moving from a physical appliance license to a virtual appliance license, but the functionality is the same, and then really it's transparent to the user.
No, I have a question regarding the nightly batch process. So we have a couple of databases that exchange data during the night. It takes about 4 to 6 hours on-prem.
Okay.
does any of these plug-in will help?
They do, and a couple things. You know, we actually find a lot of people are starting to move batch data to the public. Let me tell you a story real quick. If someone did it, had a customer, they're a drive manufacturer. They sold the entity that had their high-performance computing platform, their NVIDIA cluster, that actually did all their math calculations. How high should a head float off a drive when it needs to spin, and where is the magnetic strength, right? I mean, they have thousands of computations. They run iterations over and over and are very highly mathematical, and they decide, how should I manufacture this drive? Hey, I'm going to fill it with helium now. How does the head height need to change? I need to make the magnet stronger. So they sold their product. The cost to replace their high-performance computing cluster was $1 million. So instead, we set everything up to run with spot instances in AWS. We used a 70,000 core spot instance job. Okay? So it normally took them a month to run all the math calculations with their cluster they owned for a couple of years. Asset, it was theirs, they owned it, but it took a month to run the whole set of calculations that engineering required to get the answer of what is the right set of parameters for this new thing we're going to manufacture and ship. They ran the entire thing in AWS in, I think, a day, and it cost them $8,000. Okay? So they used spot instances, the whole thing ran there, 70,000 core job. Now, we did have to do something we didn't have to do before. All the manufacturing data that backed up, so the whole working set of data that needed to be fed into the math calculation, we did have to use a replication product to get the manufacturing working set there. So it took a couple days to send gigs and gigs and gigs of data to them. So one of the things, a lot of these products, though, they do have optimizations in them. They won't replicate zero blocks. They'll, if I had my change rate was 5%, but actually a lot of it was just rewriting the same thing over and over and over, zeros or ones. They'll actually compress that down. And so instead of sending 40 gig over the wire of change data, I'm only sending 5 gig because I've compressed it and optimized it. So a lot of times the products that are actually helping you with this, they are doing a lot of intelligence in the process to actually make it faster. So rather than just blowing it up and sending it all across the wire, sometimes you do end up with the replication that just takes it. I think you're going to see this more and more. I think as you start to see IoT and other things, data gravity is probably the #1 problem in probably moving things and also migrating. Adopting AWS faster, data gravity is probably the #1 problem. And there's a lot of startups and other products that are actually doing a lot to fix that. But adjacency is usually the #1 problem. I have to do something, but I have terabytes of data right here that I need to be next to for it to happen quickly. More questions? You have time, don't be shy. All right, well, I appreciate everyone's time. Thank you for coming. Hope you enjoy the rest of the show. I'll be around a little longer if you want to ask your question privately, perhaps. Appreciate it.